Hello friends, welcome to Tips and Tricks in Mathematics. This is for class 12 students and the topic of discussion is application of derivatives. In this video, we will be focusing on solutions to previous year questions. In the first problem, the edge of a variable cube increases at the rate of 5 centimeter per second. It is a cube. The rate at which the surface area of the cube increases when the edge is 2 centimeter. Let edge equal to A. So A is edge of the cube. Then it is increasing at the rate of 5 centimeter. So dA by dt is equal to 5. We need to find the change in the surface area. So we need to find dA by dt at A equal to 2. This is what is required to be found out. But what is A? A is nothing but 6A square. That is the surface area of cube. So dA by dt equal to 12A. Now we need to put A equal to 12A into dA by dt also we need to add. So 12 into A, we'll write it like this. dA by dt, now A equal to 2 will be 12 into 2 into dA by dt is 5. So this is equal to 120. So the correct option is B. Find dimensions of a rectangle of perimeter 12 cm which generate maximum volume when swept along a circular rotation, keeping the shorter side fixed. So let this rectangle be xy, and when we generate a cylinder we rotate about this axis. So like this we rotate about this axis. So it will be rotated like this. So we'll get a cylinder of radius y. Radius will be y and height will be x of the cylinder. Also it is given that perimeter of this rectangle is 12. So 2 into x plus y equal to 12, or x plus y equal to 12. Y equal to 12 minus x. We can put it like this. Now what is the volume of cylinder we need to find? We'll generate maximum when swept along a. So volume of cylinder is pi r square h. Correct? But r is y, so pi y square into h is x. We put y equal to 12 minus x from here, equal to pi 12 minus x the whole square into x. This will be x plus y will be 6. So this will be 6 minus x. This goes down. So this will be 6 minus x the whole square. Now we need to find dv by dx. Correct? We will find it out. Pi into 6 minus x the whole square into derivative of x is 1 plus x into derivative of 6 minus x the whole square is 2 into 6 minus x into minus 1. Now to get maximum or minimum we have to equate this to 0. Once we equate this 0, we can write it as pi 6 minus x, 6 minus 2x, 6 minus 3x, it will be equal to 0. This will give x equal to 6 and 3. When x is equal to 6, in this equation when we put y will be 0. And when x equal to 3, when 6 minus 3x is 0, x will be 2. So when x is equal to 2, y will be 4. But there is a finite dimension for x and y, so this is not feasible. So we will go with this option, x equal to 2 and y equal to 4 as the solution. We can also check easily that d square v by dx square, the second derivative, because we want to show this as maximum. The first derivative condition only ensures it is maximum or minimum. So second derivative condition is used to check the maximum, whether it occurs at the maximum. So this will be equal to minus 24 pi plus 6 pi x. We put x equal to 2 here. So we get this as minus 12 pi, which is less than 0. So at x equal to 2, it is maximum. Volume is maximum. Y equal to 2. This is the dimension of the rectangle. Find the interval in which the function is always increasing. To get an increasing function, f dash x must be greater than 0. So let us find f dash x for this, equal to 1 minus 1 over x square. This is x square minus 1 by x square. So this should be greater than 0. Since this is square, this is always positive. So x square minus 1 should be greater than 0. When this will happen? Whenever x is less than 1, and also when x is greater than 1, x square minus 1 will be greater than 0. So what is the range of the x? Range of x is minus infinity to minus 1, 1 to infinity. This is the range of x. So x takes value between minus infinity to minus 1 and 1 to infinity. In this problem, we need a ladder is fixed of length h to a wall. So this is the wall. A ladder is fixed to here at a distance y from the wall. This ladder of height h, and this is the vertical height x. We need to find a relation between y, h and x. So clearly from Pythagoras theorem, we can write y square equal to h square minus x square, implies y will be square root of h square minus x square. What is the area of this triangle? Area of this triangle is given by half xy. Y is already known, so half x square root of h square minus x square. So this is area, the triangle we got. Now we need to find in the next part of the show that the area of the triangle is maximum at the critical point. What is critical point? Critical points means dA by dx will be 0. So we got already A is, we did the last page, half xy equal to half x square root of h square minus x square. So we find dA by dx equal to half square root of h square minus x square into derivative of x is 1 plus 1 by 2 square root of h square minus x square into derivative of minus x square minus 2x. This we have to equate it 0 to get the critical point. So what if we equate it to 0? We will get h square minus 2x square equal to 0, implies x equal to h by root 2. Now we substitute x in the equation, y equal to, we know that we have done it earlier, y equal to square root of h square minus x square. We substitute this x here into this. So we get y equal to square root of h square minus x square. X square is h square by 2. So this will be also h by root 2. So we see that x is also h by root 2, y also h by root 2. Area maximum will be half into h by root 2 into h by root 2 equal to h square by 4. Also we need to show that this is maximum. So what we do? We can find the second derivative and show that it is less than 0. B square by dx square. We can find half minus 4x square minus x square minus half. We are finding derivative of this again, plus h square minus 2x square x h square minus x square minus 3 by 2. So now in this we put x equal to h by root 2. So d square by a by dx square. We put h equal to x equal to h by root 2. We already found, and we observe that this becomes minus 2, which is less than 0. So this is a point of maximum. In this problem, find from the slope of the curve, we need to find the maximum of the slope of the curve. So this is tricky. What is slope of the curve is given by y dash. This is the basic equation. From y dash we have to get the maximum. So we need to put y double dash and take its derivative. So slope is, say, s equal to y dash equal to minus 3x square plus 6x plus 8. Now slopes maximum, so we have to find ds by dx or y double dash minus 6x plus 6 equal to 0 to get maximum or minimum. This gives x equal to 1. So at x equal to 1, y will be, we can find minus 1 cube plus 3 plus 8 minus 20, 8 plus 3 11, 11 minus 21 is minus 10. So the coordinate is 1 and minus 10. 1 and minus 10. B is the correct answer. Let the volume of a metallic hollow sphere. Hollow sphere is, its volume is 4 by 3 pi r cube minus r cube. R is the outer radius and r is small r is the inner radius. If the inner radius increases at the rate, so dr by dt is equal to 2, and the inner and outer radius are 2 and 4. So r equal to 2, capital R is 4. So we need to find the rate of increase in the outer radius. So we need to find dr by dt. So we can easily do, this is dy by dt equal to 4 by 3 pi 3r square dr by dt minus 3r square dr by dt. Now this is equal to 0. Why? Because volume of metallic hollow sphere is constant. When volume is constant, its derivative is 0. So if you put this equal to 0 and just substituting r equal to 4, r equal to 2, r equal to 4 in this equation, we can easily find dr by dt given small dr by dt as 2. We can easily get dr by dt will be half. In this problem, a carpenter needs to make a wooden cuboidal box closed from all sides, which is a square base and fixed volume. He is short of paint and required to paint the box, and he wants the surface area to be minimum. On the basis of the above information, answer: take length equal to breadth equal to x and height equal to y. We need to find the surface area in terms of x and y and the volume. So what is volume? Volume is x square y for this wooden box. Height is y and the base is equal x into x. So this will be volume. Similarly, surface area will be 2x square top and bottom plus 4xy on the four sides. This will be the surface area. So from this we can get y equal to v by x square. So we need to find ds by dx. ds by dx. So SC will be 2x square plus 4x into v by x square. So we can easily find the derivative. ds by dx equal to 4x minus 4v by x square. Now we need to find the relation between x and y such that surface area is minimum. So we equate ds by dx equal to 0. So we implies 4x minus 4v by x square equal to 0. This will give v equal to x cube. But we already seen earlier v is equal to x square y. So this implies x is equal to y. From these two equations we find x equal to y. This is the relation between x and y. We can easily show that the second derivative d square s by dx square is equal to 4 plus 8v by 8x cube, which is always greater than 0. So the surface area S is minimum at x equal to y. In this problem, we are given a function this. We need to show whether it is increasing, decreasing, or has maxima at this point. So f dash x, let us find, equal to 2 minus sin x. What is the maximum and minimum value of sin x? Can take value between 1 and minus 1. So whatever values be between minus and 1, this f dash x will always be greater than 0, because 2 minus sin x will be always greater than or equal to 0. We can add here. Let's put this minus sign here and then add 2 here. We will get f dash x always greater than 0. So it is an increasing function. A cylindrical water container has developed a leak. The water is leaking at this rate, so dV volume is reducing to minus 5. Radius is 15 centimeter, and at height equal to 2 meter we need to find dH by dt. This is the question. So what is the volume of a cylinder? Pi r square h. R is 15, so this will be 225 pi h. So we can write dV by dt equal to 225 pi dH by dt. What is dV by dt is minus 5 here given. So we can find dH by dt as minus 5 by 225 pi equal to minus 1 by 45 pi. So we got dH by dt as this. Now we need to find dH by dt when h is 2 meter, but dH by dt is independent of h. So dH by dt even at h equal to 2 meters or 200 centimeter is equal to minus 1 over 45 pi. Friends, with this we conclude this video. Please like and subscribe my channel so that in future more videos can be released to you instantaneously. Thank you very much, friends.